Hi, I'm John. Welcome to Sigma Connectivity. Today we're at the Antenna Lab with my colleague Victor. Hi.
Hi.
So, what do you guys do?
Well, every connected product needs an antenna in order to function. So what we do here is that we can design and prototype custom antennas or conduct measurements on existing ones to ensure that they perform as expected.
So, how do you design and test an antenna?
Well, these days we usually start with simulations, but eventually you always end up here in the lab, and then the first step is to make a mock-up, like what we have here, which is a mock-up of a smartphone that we have developed here at Sigma.
So, is this the antenna I'm seeing down here?
Exactly, it's one of them, and it's the one that we are currently interested in. So we can see here that we have soldered a coaxial cable directly to the antenna, and that allows us to connect it to this instrument over there, which is what's called a VNA. And that allows us to measure the antenna characteristics.
So, what I'm seeing on screen here, is that what the antenna radiates, or what am I looking at?
So this is what's called the return loss. And
return loss?
Yes, exactly. And that measures how well matched the antenna is. And what that means is that it measures how much of the transmitted power actually goes into the antenna compared to how much is reflected back to the radio.
Wow, that's really interesting.
Yeah, and it varies with frequency. So we can see here that we have a pretty good resonance here in the sort of mid to high band range, which is the range that this antenna is designed to function at.
Okay.
However, it's important to note that just because an antenna is well matched does not mean that it actually radiates well. And for that, we need to use measurement chamber. We have two reverberation chambers right next to the antenna lab, and they are quite compact and fast to use. So during the design phase, we go there all the time and just measure to ensure that we have good performance. However, because of the reverberation method, we can only get a figure for how much power is radiated.
Okay.
Now, usually that's exactly what we need. We're not interested in anything else. But sometimes we need more detailed measurements, particularly when you're at the end stages of a project.
So what do you do then?
Well, we have a large anechoic chamber that we need to use then.
Can you show me?
Absolutely. So this is our MVG chamber.
Okay.
So here we can do two types of measurements.
Yeah.
So we can do what's called a passive measurement, and that is a true antenna measurement. So you can get things like efficiency, gain, or radiation pattern. But we can also do active measurements. And active measurements means that you turn on the radio in the device and you measure the whole chain. So it's a full systems level test of the whole device.
Wow.
So you can see how it performs more like in real life, and you can measure how well it transmits and how well it receives.
So what kind of radio technologies do you measure here?
We can measure pretty much anything that we can get an instrument for, like we have here. So anything from like 4G, 5G to Wi-Fi or Bluetooth.
Cool. Can I go inside?
Absolutely.
So, Victor, this room looks amazing. What the heck do you guys do in here?
Well, this is where the actual measurement is done.
Okay.
So during a measurement, you place your device here on the mast, and then you measure the radiation in each direction using these probes on the arch.
So that's all of these are like radio receivers?
Yeah, receivers and transmitters, depending on which direction you want to measure.
Okay, what happens then?
Well, then the mast rotates, and you do the whole thing again until eventually you measure the whole sphere. And that's how you get the radiation pattern.
Okay.
And then you can measure only with these 15 degrees between the probes, which is because we have 24 probes in the ring. But if we need more precise measurements, we can do oversampling.
What is oversampling?
Well, oversampling means that you can tilt the whole tower and measure basically in between the probes.
Okay.
So then we get more accuracy, but it takes longer time.
So you get higher resolution, but it takes longer time.
Exactly.
So can I test this? Can you measure my phone?
Sure.
So, is this like the radio field of my phone?
Yes, so this is the radiation pattern, the 3D, and what we have here are 3 different cuts of the same field.
Okay, so how does the work that you guys do here in the radio labs or antenna labs affect real-world products?
Well, everything these days needs to have an antenna, so you need to make sure that it meets both regulatory and carrier operator requirements, as well as the user experience.
Okay.
Because you don't want to have dropped calls or bad performance when you watch YouTube on your phone. But even when it's not phones, everything these days, you have a smartwatch, you have headsets, and you want them to just work.
So pretty much any industry needs this work.
These days, even cars are completely complex products where everything has multiple antennas.
It's been super fascinating to be here at the Antenna Lab. Thank you so much, Victor. If you reach out to us, we can book you a lab tour and you can come here and see our labs for yourself. Don't forget to like, subscribe and comment if you find this video interesting. I'm John, this is Sigma Connectivity.